Hey everyone! Today, we're going on a journey to explore one of nature's most powerful artists, which is the wind. We're diving into the world of Eolian desert system. Now, Eolian might sound like a complicated word, but it's actually a simple one. It just means driven by or related to the wind. So for this entire presentation, whenever you hear Eolian, just think wind power. So I am Aaron De Vargas together with my groupmates Miss Hannah Montañez and Mr. Marcelino Mingorio, and we're excited to guide you through this journey. So what exactly are these alien processes? In the simplest terms, they are all the ways that wind shapes the land. It does this by doing three main things, like eroding or wearing down rocks and soil, transporting or carrying sand and dust, and depositing or dropping the material somewhere new. For this to work, you need a perfect setup, a dry place with lots of loose sand and not many plants, like a desert or a beach. In these places, wind becomes a fantastic sorter, picking up and separating sediments by their size and weight. So, why does this matter to us? Well, first, it creates the breathtaking landscape you see in these pictures, the majestic sand dunes and vast plains. Second, and this is the real magic for geologists, every time the wind deposits sands, it's like writing a page in Earth's diary. These layers build up over millions of years, creating a sedimentary record that allows us to identify ancient deserts and rocks today. Finally, the wind-blown dust from these areas travels across the globe, affecting our climate and even fertilizing soils far away. So to sum it up, alien processes are the wind's way of building, sculpting, and leaving a historical record of our planet. It's a powerful natural force constantly at work. So to further elaborate you how the wind moves sediments, let me introduce you my friend, Miss Hannah Montañez.
Hi, my name is Hannah Joanna Montañez and I'm here to tackle the how wind transports and deposits sediment. Wind transports sediment in three distinct ways, determined by particle size and weight. First, we have suspension, and its mechanism is the lightest and smallest sediments particles like fine dust and sand are carried high into the atmosphere and can remain suspended for long periods, traveling hundreds of kilometers. And its analogy to water is similar to how fine silt and clay particles are carried long distance. And also, it is like particles, fine silt and clays like dust. Next is we have saltation. Saltation and its mechanism is a medium-sized particles are lifted from the surface, bounce or skip through the air for a short distance and then land often dislodging other particles. And its analogy to water is similar to how pebbles and sand grains are moved along. And the result is responsible for the formation of dunes and ripples. One saltation grain can knock others into motion. Now we also have traction, or we can call it surface creep, and its mechanism is a larger and heavier sediment particles are pushed or rolled along the ground, surfaced by a force of a wind. And its analogy to water is quite similar to how large pebbles are rolled along a river by strong currents. And its result moves the larger particles that accumulate on dune surfaces. Because this is the part when the grains are too heavy to lift but are rolled or pushed along the ground by the impact of saltation grains. Okay, next slide. We have here the major features formed by wind deposition. First is the sand seas, or we can call it ergs. It is a vast, extensive areas covered by sand dunes and represent the largest Eolian deposits. Example, the Rab al-Khali is empty quarter in Arabia. Next is Losses deposits. It's extensive blankets of fine-grained wind-blown silt and clay formed from settled dust or suspension load, and it creates very fertile soil like Losses Plateo in China. And dune types. Dunes are classified by their shape and relationship to wind direction. For example, the sand dunes in the Philippines, while the large desert like dune system are not typical in the Philippines due to its humid, tropical climate. Coastal dunes can be found in certain areas. An example is the Poay sand dunes, also known as Bantay Bimaboy in Ilocos Norte. These dunes are formed by wind action and sandy coastal sediments. Activities like sandboarding and off-road driving are popular here, but essentially to manage the activities to prevent excessive erosion. And next we have Brachan, consent-shaped individual dunes in areas with limited sun, and transverse, wavy ridge-like dunes perpendicular to wind direction abundant sun, and longitudinal or linear, long straight dunes parallel to the dominant wind, and parabolic is a U shape with arms anchored by vegetation common in coastal areas. And lastly, we have star, gradually symmetrical with multiple arms formed in areas with variable and wind direction. Okay, next slide. So we have here the anatomy of a dune and how it moves. First, we have the toe slope, or we can call this the windward side. This is the prevailing wind and has a general slope extended to the crest. So the sun grains are pushed up this slope by saltation. And we have here the crest, the highest point of the dune. Then we have here the lee side, or we can call it the slip face. This is the leeward side, sheltered from the wind, featuring a steeper slope. The angle of this slope, known as the angle of repose, is typically around 34 or 30 degrees, or 32, 34 degrees. Then we have the process of dune migration. We have erosion and transport, and wind moves sand up and windward side. The avalanching sand accumulates to the crest until it becomes unstable and avalanches down the steep face. Then we have the advance. This continuous process causes the entire dune to slowly migrate downwind. And lastly, we have preservation. The avalanche deposit cross beds are buried and preserved, create the stratigraphic record. In other circumstances, in conclusion, as sand moves up the toe slope to the crest, the pile becomes too steep and collapses under its own weight, causing sand to avalanche down the steep face. Over time, this process causes the entire dune to move in the downwind direction. The speed of movement varies, with smaller dunes generally moving faster than larger ones. Vegetation can stabilize dunes, preventing their movements. And that's all.
So let's now proceed to the stratigraphic makeup that will be discussed by Mr. Marcelino Mingoria.
Good day everyone, I'm Marcelino Mingorio, one of the presenter, and today we are going to tackle about the architectural blueprint of ancient dunes. Ancient dunes can be identified in rocks through several important structures. The most common feature is cross-bedding, which forms when sand moves down the steep slip face of a dune. This appears as a large slanted layers that can be meters thick and show how dunes migrated over time. Another structure is grain flow cross stratification, which happens when sand avalanche down the slip face, creating thicker layers with coarser grains. Grainful stratification forms when wind drops find sand into the slope face, producing thin, gently inclined layers. Lastly, wind ripple lamination is usually created by ripples on the dune surface, usually found on the windward side, and result in very thin wavy layers. Together, these features tell the story of how dunes were built and reshaped by the wind. When looking at the ideal sequence of a dune, geologists can see how it developed from bottom to top. At the base are interdune deposits, which are flat layers that may contain mud cracks or ripples from water. Above these are wind ripple laminae, which are thin layers made by ripples on dunes' windward slope. Moving upward through cross-bedding appears as a curved, scope-shaped layers, often created by smaller dunes. The main body of the dune is represented by large-scale planar cross-bedding, which consists of thick, steeply inclined layers showing the advance of the sleep phase. Finally, the sequence is capped by a score surface, an erosional layer which were newer dunes cut into the older ones. This complete set of layers helps geologists understand how dunes move and change through time. A famous example of preserved ancient dunes is the Navajo Sandstone found in the western United States, particularly across Utah, Arizona, and Colorado. It formed during the early Jurassic period about 190 million years ago and represents one of the largest sand seas in the Earth's history. The Navajo Sandstone is a massive, reaching over 700 meters thick in places, and is known for its sweeping crossbeds that show the scale of ancient dunes. Its color range from white to pink because of well-sorted quartz sand mixed with iron. The formation also preserves rare features such as dinosaur tracks and evidence of interdune deposits. Altogether, it reveals that a vast desert, similar to today's Sahara, once stretches across western North America.
So that would be all for our presentation. Have a great day.